This is the homework for Paul Recorder's lesson number 84. He wanted us to increment a binary counter using the button we just did last week that we just set up debouncing for last week. And what I'll do is a quickie peek at the software here. If you look at the software, I've got machine import pin and timer. Import time. I use that for the ticks underscore milliseconds stuff that requires time to be imported. Then I define the pins for the 4 LEDs. In my case, it's 13, 12, 11, and 10. If you look down to the board, you'll see I've got 4 resistors here and some wires going up on the left side of the Pico and pick those pins up. It was a little hard to get those. Make it look neat anyway. Then I started doing it. I realized it was going to wash out the camera, so I put a blue piece of tape on there. Okay, anyway, from here, I defined the butt pin to pin 20. Then I defined the press pin equal to 1. And then T up. What do you call it? The T up and equals time dot ticks milliseconds. And then T down dot times milliseconds. And then I set up this is defined the old butt state. Now, if you go down here, let's go up here. And we'll go up here to down here. We've got the watch the button. This is the interrupt triggering the button. And if I get this guy right here, you can see it trigger the button on the rising time and the falling time. And then I call out the internal switch. I'm not sure what Paul was in that stand for, but INT switch. And here I put pin, and I guess you put anything you want. Just something's got to be in there. This thing is not happy. Anyhow, and then we do a global. I make a press T up, T down, and butt state hold global variables. Down here, I set up the new butt state by reading the watch button and getting the value. Now I know what state the button is in, and down here I do a definition. If it's a 1, then it's a T down, and I take the time dot ticks measurement there. So the T down now becomes whatever that time dot ticks is. Then if it's a time butt state, if it's a 0, then you go T up time dot ticks and milliseconds. In this next line, we see that the button has been changed, and then we take the T down and minus the T up. It has to be greater than 25 milliseconds. Otherwise, you get all kinds of bouncing going on. Okay, now down here, when I was trying to figure this out, I'm trying to figure out where I'm going to put this binary counter. Finally landed on this. It works pretty good. Anyhow, I got a 1 LED value. It's a press. I'm using the press as the counter. And it's a press N1. That makes it a 1-bit. And this is a bitwise binary counter. And then we have 2 LED dot value. If it's a 2 LED dot value, it's press and 2, which makes it a 2-bit. Then the 4 LED, and it makes it a 4-bit. And an 8 LED makes it an 8-bit. And after it gets counting, it goes down here and keeps incrementing until it gets to 16. At 16, it's the modulus output becomes a 0 and it goes back to 0. And then at this point here, we do a little baggage control and make the old butt state equal to the new butt state. And here, we got the watch button with the pull downs. Okay, now down here, we just have the while true and pass. And if the keyboard interrupts stuff, so we could reset this program, turn all the LEDs off. Okay. If I can Control C, I get if I could get a hold of it. Oh, darn it. If I do a Control C, you get up here so you can see it. The program prints halted and resets all the LEDs to 0. Okay, now let's go ahead and run this guy. It's running, so I'm going to go through and hit the button one time because it was 0, now it's a 1. That's a 2. That's a 3. That's a 4, 5, 6, and 7. So you got the 1-bit, 2-bit, and the 4-bit lighted up here. And if the next one will break up to 8, which would be the last LED in the line there. And then we got 9, the 8 and the 1. 8 and the 2 is 10. 8 and the 1, 1 and a 2 is 11, 12, 13, 14, 15, and next one will go to 0 because that's the modulus thing. There it goes. Okay, that's my homework, and I appreciate you doing these videos, Paul, and goodbye, guys. See you next week.